LED stands for light emitting diode. They are being used in many devices like digital clock, remote control, LED TVs, or just as LED lights that illuminate rooms and roads. But what is LED and how do they glow? Well, to understand this, we first have to understand what are diodes. Diodes are basically semiconductor. As many of you know, on basis of electrical conductivity, materials can be divided into three main categories: conductor, semiconductor, and insulator. Now, conductors show high conductivity. They are used in high tension and normal wires for transporting currents. Aluminum, copper are the main examples of conductors. Insulators do not show any conductivity. And most importantly, the conductivity of semiconductors lies between these two, conductor and insulator. So semiconductors have a conductivity which is greater than insulators but less than the conductors. Current flow in semiconductor means flow of electron and holes inside the semiconductor. In pure semiconductor, number of free electrons are very less. As a result, pure semiconductors has minimum conductivity. To increase the conductivity of the semiconductor, we mixed impurities in it. Upon mixing the impurities into the semiconductor, they either increase the number of holes or number of free electrons in the semiconductor. As a result, the conductivity of the semiconductor increases. If the impurities increase the amount of holes inside the semiconductor, then the semiconductor becomes p-type semiconductor. If the impurities increase amount of free electron inside the semiconductor, then it's called n-type semiconductor. Now a diode is made by adding two types of impurities inside a semiconductor, making a junction-like structure, like this. At the junction, there is an energy gap, which is called band gap. Under the band gap, there is valence band. Energetically, the holes stay in the valence band. Above the band gap, there is conduction band. Energetically, the electrons stay here. So as per the energy diagram, there is a difference of energy between the holes and the electrons. Now we know physically the electrons are in N region and holes are in P region. When current is supplied to the diode due to the electric field, holes and electrons both started to travel towards the junction and recombine with each other and release energy in terms of photon. This is known as electroluminescence. The energy of the emitted photon is same as the band gap or the energy difference between the conduction band and the valence band. As we know, photons are actually light quanta, so this is the light what we can see in the LEDs. The color of the emitted light depends on the energy gap or band gap. According to famous E=h nu formula, we can calculate the color of the emitted light. Different PN diodes have different value of band gap, so by changing the band gap, we can produce different colors of LED. Like blue LEDs are produced by aluminum gallium nitride semiconductor and green LEDs are produced by indium gallium nitride semiconductors. White LEDs can be produced by two popular ways. One is use individual LEDs that emits three primary color red, green and blue and mix them all together to form white LED. Or in other technique, we use phosphorus material as a coating of the LED to convert monochromatic light into white light. So, this is how LEDs are made and they glow and emit lights. Hope you like this video. If you are new to this channel, then subscribe to our channel for future videos.